In the heart of the English countryside, 50 miles north of London, stands a Victorian mansion that changed the course of human history. But this isn't a story about Enigma. This isn't about Alan Turing's famous code-breaking triumph. This is about something far more secret, far more powerful, and hidden for decades after the war ended. This is the story of Colossus, the world's first programmable electronic computer and the brain that could read Hitler's mind. While the world celebrated the breaking of Enigma, another code remained unbroken, more complex, more dangerous. The Germans called it Geheimschreiber, the secret writer. The Allies called it Tuni. And for years it transmitted Hitler's personal orders directly to his generals across Europe. Every strategic decision, every troop movement, every secret plan flowed through this impenetrable cipher. Until one day when a tired German operator made a single catastrophic mistake. August 30th, 1941, British listening stations in the south of England picked up something unusual. A German transmission over 4,000 characters long was sent from Athens to Vienna. Nothing unusual about that, except what happened next. The receiving operator sent back a message, "Didn't get that, send again." The German operator, exhausted and frustrated, did something unthinkable. He retransmitted the entire message without resetting his cipher machine. Worse yet, he abbreviated several words the second time around to save time. He'd just handed the British two versions of the same message, encrypted with the same key settings. At Bletchley Park, a 23-year-old chemist turned mathematician named Bill Tott received these intercepts. What he did next would be called one of the greatest intellectual achievements of the 20th century. Without ever seeing a Lorentz machine, without any knowledge of its internal mechanics, Tutor reverse-engineered the entire cipher system using pure mathematical logic. For months, Tutor worked with just pencil and paper, analyzing patterns in the gibberish. The Lorentz machine used 12 rotors, creating astronomical combinations, 10 to the power of 19 possible settings. That's 10 quintillion combinations. Hand calculation would take lifetimes. The breakthrough came when Tutor realized the machine used a binary additive system. Each letter was converted to a 5-bit code, then scrambled by the machine's 12 wheels. He mapped out the entire logical structure wheel by wheel without ever seeing the device. German engineers had spent years perfecting their unbreakable machine. Bill Tutt broke it in his head. But breaking the cipher was only the beginning. The real problem was speed. Enter Max Newman, a Cambridge mathematician who understood that no human team could process these messages fast enough. By the time cryptanalysts manually worked through the calculations, Hitler's orders would already be executed. Rommel's tanks would have moved, U-boats would have struck, armies would have advanced. Newman had a radical idea: build a machine. Not a mechanical calculator, but something entirely new, an electronic computer that could process thousands of calculations per second. In 1943, this was science fiction. The technology barely existed. The British government turned to Tommy Flowers, a telephone engineer at the Post Office Research Station in Dollis Hill, London. When Newman explained what he needed, Flowers said it was impossible. Then he went home and started building it anyway. The key technology was the thermionic valve, what Americans call the vacuum tube. These glass bulbs could switch electronic signals on and off at incredible speeds, but they were notoriously unreliable. Engineers believed that using more than 100 in one machine would result in constant failures. Flowers proposed using 1,500 of them. Everyone said he was insane. The machine would never work. The valves would burn out within hours. It was a waste of resources during wartime. Flowers was told to abandon the project. He refused. Using his own money and working in secret, he continued development. For 11 months, Flowers and his team worked around the clock in the basement of Dollis Hill. They built circuits that had never been attempted before. They designed custom components. They invented new engineering techniques on the spot. The project consumed Flowers financially and physically, but by December 1943, he had something to show Bletchley Park. On January 18, 1944, Colossus came alive in Block H at Bletchley Park. It was enormous, the size of a living room, weighing over a ton. Racks of equipment stretched from floor to ceiling. 1,500 vacuum tubes glowed like a wall of amber lights. Punched paper tape containing the encrypted German message fed through a reader at 5,000 characters per second. The machine didn't just calculate, it could be reprogrammed with plugboards and switches to test different cryptographic hypotheses. This was programmability, the fundamental concept of modern computing, appearing for the first time in human history. The tape reader was an engineering marvel. Paper tape had to move at 30 miles per hour without tearing. Special sprocket holes kept it aligned. Photoelectric sensors read the punched holes and converted them to electronic pulses. Any jam or tear would destroy hours of work. When Flowers switched on Colossus for the first time, the room held its breath. The machine hummed to life, valves glowed, relays clicked, and then it worked. Against all predictions, the vacuum tubes didn't fail. The machine ran continuously, processing calculations that would take humans weeks in just hours. The machines were operated by Women's Royal Naval Service members, called Wrens. They worked in shifts, feeding tape, adjusting settings, monitoring output. These women, many barely out of their teens, operated the world's first computers. They were sworn to absolute secrecy. Most didn't even know what the machine was doing, only that it was vital to the war effort. Dorothy Dubuisson, Eleanor Ireland, Betty O'Connell, names history nearly forgot. They operated Colossus through bombing raids, through exhaustion, through the pressure of knowing that lives depended on their accuracy. One mistake in setting a plug or switch could mean Allied soldiers walking into an ambush. By early 1944, Allied intelligence was reading Hitler's personal communications with his field marshals, not summaries, not interpretations. The actual words of the Führer himself, sometimes within hours of transmission. On June 4, 1944, 2 days before D-Day, Colossus decoded a message that changed everything. Hitler had ordered Rommel to keep panzer divisions stationed near Calais. Convinced the main Allied invasion would come there, the Germans had fallen for Operation Fortitude, the elaborate deception campaign. But without Colossus confirming Hitler's belief, Eisenhower might have delayed the invasion. On June 6, as Allied forces stormed the beaches of Normandy, they did so knowing the exact positions of German reserves. They knew which divisions were stationed where. They knew the command structure. They knew that Rommel was away from his headquarters. All because Colossus had decrypted the tunny traffic. General Eisenhower later said that intelligence shortened the war by 2 years. He was being conservative. The success of Colossus Mark I led to an immediate demand: build more and make them faster. By June 1, 1944, just 5 days before D-Day, Colossus Mark II was operational. It used 2,400 vacuum tubes and ran 5 times faster than Mark I. Tommy Flowers and his team had gone from impossible to building the world's most advanced computer in less than a year. By war's end, 10 Colossus machines operated at Bletchley Park, processing thousands of messages. Each machine represented a quantum leap in human technological capability. In July 1944, Colossus decrypted messages revealing the conspiracy to assassinate Hitler. The Allies watched in real time as the German officer corps tore itself apart. They read the names of conspirators before Hitler's Gestapo arrested them. They saw the paranoia spread through German command structure. Every strategic decision Hitler made, every order he sent, every doubt he expressed to his commanders, the Allies knew. It was as if they had a spy sitting in Hitler's war room, transcribing every word. December 1944, the Ardennes Forest. Hitler launched his last major offensive in the West, the Battle of the Bulge. The attack caught Allied forces by surprise, creating panic and chaos. American lines buckled. For a moment, it seemed Hitler might split the Allied armies and reach the port of Antwerp. But within 48 hours, Colossus decoded Hitler's orders to his commanders. The Allies learned the true objective, the commitment of reserves, the fuel shortage plaguing German tanks. Eisenhower repositioned forces accordingly. What could have been a catastrophic defeat became a turning point. By January 1945, German resistance in the West collapsed. The Colossus team at Bletchley was processing messages faster than the Germans could send them. Intelligence officers delivered Hitler's orders to Allied commanders before some German generals received them. As Soviet forces closed on Berlin from the east, Colossus revealed Hitler's desperate final instructions. The Allies read his order to flood Berlin's underground tunnels, potentially drowning thousands of civilians. They intercepted his demands that German cities fight to the last man. They saw, in real time, the collapse of the Third Reich's command structure. On April 30, 1945, Adolf Hitler committed suicide in his bunker. Within days, Germany surrendered, the war in Europe was over. And Colossus, the machine that had predicted Hitler's every move, fell silent. May 8, 1945, Victory in Europe Day. As crowds celebrated in London streets, Winston Churchill signed a secret order. Everything related to Tunney and Colossus was to be destroyed. The machines were to be dismantled, the blueprints burned. The engineers sworn to secrecy under the Official Secrets Act, not for years, but forever. 8 of the 10 Colossus machines were physically destroyed, smashed into pieces so complete that they couldn't be reconstructed. 2 were secretly moved to GCHQ, Britain's Signals Intelligence Headquarters, where they continued breaking Soviet codes throughout the Cold War. Bletchley Park was mothballed. The buildings fell into disrepair. Pigeons nested in the rooms where history was made. Within 5 years, the site was nearly forgotten. Tour guides called it a wartime communication center and left it at that. Tommy Flowers, the man who built the world's first programmable electronic computer, returned to the post office. He couldn't talk about his achievement, he couldn't publish papers, he couldn't claim credit. When he applied for funding to develop commercial computers in the late 1940s, he was rejected. The committee didn't believe his claims about wartime computer development. Flowers died in 1998, having spent most of his life unable to discuss his greatest achievement. Bill Tutt, the mathematician who broke Tunney with pencil and paper, emigrated to Canada. He became a professor at the University of Waterloo, making groundbreaking contributions to graph theory. His students had no idea he'd helped win World War II. The Official Secrets Act kept him silent for 30 years. While Colossus remained classified, America announced a different computer to the world. In February 1946, the University of Pennsylvania unveiled ENIAC, the electronic numerical integrator and computer. Newspapers called it the first electronic computer. It was celebrated as an American triumph of engineering. ENIAC was impressive: 18,000 vacuum tubes, 30 tons of equipment capable of 5,000 additions per second. But it wasn't first. Colossus had been operational 2 years earlier, was programmable, and had already won a war. The American engineers who built ENIAC, John Bletchley and J. Presper Eckert, had no knowledge of Colossus. They couldn't. It was still classified. So they proceeded independently, developing similar technologies from scratch. When they claimed credit for inventing the electronic computer, they believed it was true. For decades, computer science textbooks taught that ENIAC was first. Students learned that the computer age began in Philadelphia in 1946. The true story remained locked in British government archives. Even Alan Turing, whose work on Enigma was eventually revealed, remained silent about Colossus. He'd worked on different projects at Bletchley and had only peripheral involvement with Tunney, but he understood the importance of keeping the technology secret. When he proposed building computers at Manchester University after the war, he couldn't reference Colossus to support his designs. Turing died in 1954, still bound by the Official Secrets Act. Why the secrecy? Why destroy the machines? Why silence the engineers? The answer lay in the Cold War. British intelligence realized that the Soviet Union was using communication systems nearly identical to the German Lorentz machines. The same mathematical principles that broke Tunney could break Soviet codes. The two surviving Colossus machines, relocated to GCHQ, intercepted and decoded Soviet military communications throughout the 1950s and 60s. During the Berlin crisis, the Cuban Missile Crisis, and countless Cold War confrontations, Colossus provided Britain with intelligence on Soviet intentions. The Soviets never knew. They believed their cipher machines were secure, just as the Germans had. They transmitted diplomatic cables, military orders, and strategic planning through systems that British intelligence could read, revealing Colossus would have immediately compromised this advantage. Some historians believe Colossus gave Britain disproportionate influence in NATO strategy. While America had nuclear weapons and military might, Britain had intelligence. They could read Soviet communications, predict Soviet responses, and advise American presidents accordingly. This invisible advantage persisted for decades. Only in the 1970s, as electronic technology evolved beyond Colossus's capabilities, did British intelligence begin to consider declassification. Even then, the process moved glacially. The breakthrough came from an unexpected source. Captain Jerry Roberts, a former Tunney codebreaker, had stayed silent for 30 years. But in the 1970s, he began giving lectures about Bletchley Park's work, carefully edited to avoid classified material. His talks sparked interest in the forgotten site. In 1974, F.W. Winterbotham published The Ultra Secret, the first book to reveal that Britain had broken German codes during the war. The book mentioned Enigma, but remained vague about other systems. The British government allowed limited disclosure, carefully controlling what information emerged. Throughout the 1970s and 80s, former Bletchley Park workers began speaking publicly. Each revelation carefully negotiated with the government. Brian Randall, a computer historian, started researching Colossus in 1970. It took him 5 years to get the government to acknowledge the machine had existed. In 1975, Randall published the first technical paper describing Colossus. The computer science world was stunned. The foundation of their field had been rewritten. The first programmable electronic computer wasn't ENIAC in 1946. It was Colossus in 1944. In the 1990s, Tony Sale, a British computer engineer and museum curator, began an ambitious project: rebuild Colossus from scratch. Using declassified documents, photographs, and interviews with surviving engineers, Sale and his team spent 14 years reconstructing the machine. They faced enormous challenges. Original components were obsolete. Techniques used in the 1940s were forgotten. Surviving engineers were in their 80s and 90s, memories fading. But piece by piece, valve by valve, they brought Colossus back to life. On November 6, 2007, the rebuilt Colossus was officially unveiled at the National Museum of Computing at Bletchley Park. For the first time since 1945, the machine ran again. Vacuum tubes glowed, paper tape whirred through the reader. And in a profound moment, the machine successfully broke an encrypted message, just as it had 60 years earlier. The Duke of Kent, representing the British royal family, attended the ceremony. Surviving Colossus operators and engineers, now in their 80s and 90s, gathered to see their creation resurrected. Many wept. They'd kept the secret for over 60 years, unable to share their pride, unable to explain to their children and grandchildren what they'd accomplished. Betty O'Connell, a former Wren operator, spoke at the ceremony. "We knew it was important, but they never told us what it did. I operated this machine for 2 years without knowing I was breaking Hitler's codes. Now I finally understand." The revelation reshaped computer history. Universities updated their curricula. Museums rewrote their exhibits. Tommy Flowers and the Colossus team finally received recognition as the true pioneers of the computing age. From Colossus to the smartphone in your pocket, the line is direct. The fundamental principles Tommy Flowers pioneered, electronic processing, programmability, binary logic, underpin every digital device in existence. Every computer chip, every smartphone, every digital watch descends from the machine built in secret to beat Hitler. Bill Gates visited the rebuilt Colossus in 2008. He stood before the machine in silence for several minutes, then said, "This is where it all began. Everything we do at Microsoft, everything in Silicon Valley, started here." Let's understand the true scale of Colossus's impact. The machine didn't just help win World War II, it fundamentally altered the way in human civilization's trajectory. Historians estimate Colossus shortened the war in Europe by 1 to 2 years. Every day the war continued, approximately 1,000 Allied soldiers died. If Colossus shortened the war by 500 days, it saved 500,000 lives. That's a conservative estimate. It doesn't count civilian casualties, Holocaust victims who might have passed and been liberated sooner, or destruction that didn't occur. Colossus proved that electronic computers were practical. Before 1944, the consensus was that vacuum tubes were too unreliable for large-scale computing. Flowers demonstrated otherwise. This breakthrough directly enabled the computer revolution of the 1950s and 60s. The global computing industry is now worth over $5 trillion annually. It employs hundreds of millions of people. It has created wealth, opportunity, and technological advancement that would have seemed like magic in 1944. The foundation was laid in Block H at Bletchley Park. The Wrens who operated Colossus demonstrated that women could excel in technical fields previously dominated by men. After the war, many pursued careers in computing and engineering, breaking barriers despite social prejudice. The seeds of women in STEM were planted at Bletchley Park. Colossus established Britain as a signals intelligence superpower, a position it maintains today. GCHQ evolved directly from the techniques and technologies developed at Bletchley. Modern electronic surveillance, for better or worse, traces its lineage to Colossus. Today, Bletchley Park is a museum visited by hundreds of thousands annually. The site where secrecy once reigned is now dedicated to education and transparency. School children tour the rooms where Colossus operated. They see the rebuilt machine, touch the punch tape, and learn that ordinary people can change history. The Colossus story teaches us that the most important achievements are often invisible. While the world celebrated Enigma, Colossus worked in deeper shadow. While America claimed to invent the computer, Britain kept silent. The true heroes don't always get parades. Let's talk about what secrecy cost the people who built Colossus. Tommy Flowers spent £1,000 of his own money, roughly £50,000 in today's currency, building the first prototype. After the war, he applied for reimbursement. The government refused. They couldn't acknowledge the project existed. Flowers spent years trying to commercialize his computer designs. Companies rejected him. Universities dismissed him. Venture capitalists turned him away. He couldn't explain that he had already built the world's first programmable computer because that was classified. He watched others get credit, funding, and fame for reinventing what he'd already accomplished. In 1983, at age 78, Flowers was finally allowed to discuss Colossus publicly. By then, computer history had moved on. Most people had never heard of him. He gave some interviews, attended some ceremonies, and died in 1998, having spent most of his life unable to claim his greatest achievement. The Wrens who operated Colossus faced different challenges. They returned to civilian life, unable to explain what they'd done during the war. When applying for jobs, they couldn't list their most relevant experience. When their children asked what Mummy did in the war, they said, "Oh, I worked in an office." Many suffered from what we'd now recognize as PTSD. They'd worked under incredible pressure, knowing that mistakes cost lives. They'd worked through bombing raids, through exhaustion, through the stress of absolute secrecy. But they couldn't seek help because they couldn't explain what had traumatized them. Eleanor Ireland, a Colossus operator, said in 2009, "I carried this secret for 65 years. I couldn't tell my husband, I couldn't tell my children. When they finally declassified it, my son was angry. 'Why didn't you tell us?' he asked. 'How do you explain the Official Secrets Act to someone who wasn't there?' Bill Tutt never sought recognition. When the story finally came out, reporters called him a hero. He dismissed it. 'I was just doing mathematics. I didn't know I was saving lives. If I had, the pressure might have broken me.' Tutter died in 2002, having spent his later years as a respected but not famous mathematician. The Official Secrets Act destroyed relationships, created psychological burdens, and denied recognition to people who deserved it. The cost of secrecy was paid by individuals who could never complain. Stand in front of the rebuilt Colossus at Bletchley Park today, and you're looking at more than a machine. You're looking at the moment when humanity crossed a threshold. Before Colossus, humans did all information processing. After Colossus, machines could think, not like humans, but with their own electronic logic. The Germans believed their Lorenz cipher was mathematically unbreakable. They were right. No human could break it in time to be useful. But they never imagined a machine that could. Hitler's fatal flaw wasn't underestimating human intelligence. It was failing to imagine that humans could build something smarter than themselves. Colossus processed 5,000 characters per second. Your smartphone processes billions of operations per second. But the principle is identical. The architecture is similar. The fundamental insight that electronic circuits could be programmed to solve problems came from Tommy Flowers and his team in 1944. Every time you send an email, stream a video, or use GPS, you're benefiting from technology that descends directly from the machine built to beat Hitler. The ghost in every machine is Colossus. Consider the progression. Colossus filled a room and required dedicated electrical systems. Modern computers fit in your pocket and run on batteries. But we couldn't get from here to there without Colossus proving it was possible. In 1944, when Flowers proposed using 1,500 vacuum tubes, experts said the machine would fail within hours. They were wrong. Colossus ran continuously for years. It demonstrated that electronic computing was not only possible but practical. That confidence enabled the next generation of engineers to push further. The story of Colossus is a reminder that history's most important moments aren't always visible. While the world watched Normandy beaches and Berlin's fall, the real turning point was happening in a locked room where a machine was reading Hitler's mind. Today, a plaque at Bletchley Park commemorates the Colossus team. It lists names that should be as famous as Edison, Einstein, or Turing, but aren't. Tommy Flowers, Bill Tutt, Max Newman, and dozens of others. It honors the Wrens who operated the machines. It remembers the people who kept the secret. The plaque includes a quote from Eisenhower: "The intelligence from Bletchley Park was decisive to Allied victory." He never knew the full story. Even as Supreme Commander, he didn't have clearance for Colossus. But he understood that something extraordinary had happened in that English countryside mansion. What can we learn from Colossus? That innovation happens in unexpected places, that ordinary people can achieve extraordinary things, that secrecy has costs, that technology shapes history, that the most important achievements aren't always the most celebrated. The brain that predicted Hitler's moves wasn't a spy network or a brilliant general. It was a room-sized electronic machine built by an engineer everyone said was crazy, operated by young women no one thought were capable, based on mathematics that seemed impossible. Colossus didn't just help win World War II. It launched the information age. Every computer, every smartphone, every digital device traces its ancestry to Block H at Bletchley Park. The machine built in secret to stop fascism became the foundation of modern civilization. And for 60 years, almost nobody knew it existed.